Hello, we did this in class today. This was December 9th and preview of the quiz we have on December 10th. And so the half-life is basically the time it takes for half of a radioactive substance to decay. Not half of an atom, but if you have like a certain amount, like a billion atoms, then half of those will be decayed after one half-life. The half-lives are different for different materials, so some are very short, some are medium length, and some are very, very long. So these are some sample problems that we did in class. They relate to the lab that we did on Monday and in Tuesday in class. Actually, Monday and Wednesday in class, pardon me. So if we have 8,000 atoms of this, how much will be left after 24 days? The way that I like to think about this is I start with 8,000. This is one half-life, so the arrows represent half-lives. After one half-life, I've got 4,000. Second half-life, which is another 4 days, 2,000. Third half-life, 1,000. I work my way down until I get 24 days. So it's 4 plus 4 plus 4 plus 4 plus 4 plus 4. So I have 6 half-lives, and after 6 half-lives, I have 125 atoms, about. We know that it wouldn't be perfectly like that, but that's the best estimate. So this is now asking how many half-lives will it take for 1,600 grams of carbon-14 to decay to 50 grams. So I'm going to look at 1,600 to 800 to 400 to 200 to 100 to 50. So that's 1, 2, 3, 4, 5 half-lives. Notice again the arrows represent the half-lives. After 2.5 minutes, how much of a 4,000 gram sample of seaborgium 266 will remain? Change minute to seconds. Well, 30 seconds is half a minute. So here I've got 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. 5 half-lives is 2.5 minutes, and so I have 125 grams. After 6 half-lives, 2 grams of strontium-90 remains. How much of the sample was there originally? So here I'm working backwards. I have 2. 1 half-life before that I would have had 4. Another half-life, 8, 16, 32, 64, and then 128. So that's how many I would have had. 128 grams to start with. This one I screwed up, so I did this in class. So it should have been 9 grams nitrogen 14, 3 grams carbon 14. The other part about this is it's asking you how old it would be. I probably wouldn't ask something with this mathematically, but you should be able to add this together. So if I have 9 and 3, that means I started with 12 grams of carbon 14. After 1 half-life, it would be 6. After 2 half-lives, it would be 3. So each half-life, as shown up here, is 5,730 years. So I just add those two together. That's 11,460 years. This one is a good thinking question. Basically, if you want to use radioactivity to date something, you should have a half-life in the same general area of what you're trying to date. So if I know that this woolly mammoth is 10 to 15,000 years old, I wouldn't use seaborgium or radon because their half-lives are so short that there would be nothing left at that point. Uranium has such a long half-life, very little to almost nothing would have decayed at that point. So that wouldn't give me good data either. So with carbon-14, I would have had a couple half-lives pass, and so that's a reasonable amount to count. So with these ones, 80 atoms after 1 half-life, you'd have 40, 2, 20, 3, 10, 4, 5. 1 second here, because we start out with 400, we end up with 200, so that's 1 second is the half-life. This, I don't know why I put days, because I didn't read this. Start out with 1 million atoms. Looks like it's down to 500,000 after about 1 minute. So hopefully that helps out. I'll put that on my Google Classroom. The other thing that I can do here with Google Classroom is let you know we did go over today some of the homework that we'd had. So remember, this is a quiz review guide. These are the answers to the Taming the Dragon's Tail. And I actually, over here in the classwork, have the notes. So I have filled in notes that I did earlier. We went over some of these things, including reviewing alpha, beta, gamma decay. Those are things you definitely should know, and you should know how to finish off those reactions if given a periodic table. Okay, so hopefully that helps.